Hello again, my wonderful physics students. I must say, just before we get started, you look really good today. I don't know maybe it's something new you've done with your hair. Anyway, today we are going to do step number 2 in motion graphs. So last time we talked about making a position versus time graph, and we're going to move on from here. All right? Basically, we're going to take a position versus time graph that we made from last time, and we're going to turn that, or we're going to add to it, I guess, is a better way to say that, a velocity versus time graph. The last lecture, we kind of ended with this, and let's stop and think about what's going on here. Let's review one more time. The first section of this graph. So let's look right in here, all right? What is going on here in the graph? All right, it looks like someone is starting at the origin and they are moving at a constant speed going away from the origin. Can everybody see that? Then the question becomes, what happens in the middle section here? That one. In that section, notice what's happening. Time is increasing, but the position stays the same. So if it's a person walking, it means at this point they're just standing still. That makes sense? And then at the last section of the graph, we've got that person moving again. They've started to walk. So, alrighty, let's move forward. The last thing we talked about, and this is huge, the velocity on this graph is the rise over the run, or the slope. Okay, so going back again, what would the velocity right in here be? Okay, in this section, it's some positive number. So they have a velocity that's positive. They're moving in the positive direction. In the center section, the flat part, the rise is 0, so the velocity is going to be 0. And then again in the third section, they have a positive velocity again. All right, we're going to put some numbers to this. So I've made a graph here, and I want you to be really careful and try to go ahead and copy this graph almost exactly. So it's time to pause things. And I've tried to line things up with numbers. So if it looks like, for example, the person is moving along out to 4 seconds and we are at 8 meters, that's what it should be. So see if you can make this graph. All right, and when you're done, go ahead and start things up again. Alrighty. So the trick here is we're going to try to turn this graph into a velocity graph. Now what I want you to do is I want you to make a velocity versus time graph directly underneath this graph. So it's going to look something like this. I just went to the next slide and I added down here a velocity graph. Now notice, here's the important thing, the time part lines up exactly. I just copied them right down. I put the words velocity on the side, okay, or on the axis, I'm sorry, but I didn't put any numbers because I don't know what we're going to use yet. I don't know what numbers we need. Okay? So, go ahead and do that, and then start the video again when you're done. Alrighty. Let's figure out what the scale for our velocity needs to be. So we're going to go back up to our graph, and let's calculate a slope for the 3 different sections. Okay? Let's do the easy section first. Let's do this flat section. Okay? Right here, the slope of that line is the rise over the run. How much is that line going up? 0. So the rise of 0 over anything means the slope is going to be 0. Now let's try this one. See if you can calculate the slope of this line. Go ahead and pause me, and then we'll see what number you get. I got a slope of 2. Goes up 2 for every 1 it goes over. All right, what's the slope over here? Whoops, arrow's going that way. Slope equals, go ahead, let me finish my word. The slope equals, go ahead and calculate that one. This one's a little trickier. I get a slope of 2/3. It goes up 2 for every 3 it goes over. All right. So now, looking at this, we need our velocity to go from the biggest number to the smallest number we have for our slopes. Biggest number is 2, smallest number is 0. So let's go down to our graph, our velocity graph, and let's just put a 2 up there near the top. Whoopsie. So there's going to be 2. Let me do some erasing here. Let me get rid of this because I'm not being very neat. All right, that's better. So 2, halfway up from 2, we are going to put a 1. Let's put our 1 right there. And that's going to be 1/4, and that'll be 3/4. Let's go ahead and put numbers on these. 2.0. 1.5, 1.0, and 0.5. I just put in the extra number there so it'd be easy to see. So, all right, that's kind of step 1. We make the velocity graph. Now, this step's really important, and I think it's going to help a lot. What you're going to do is you are going to project wherever the velocity changes or wherever the interesting parts of the line are from your position graph down to your velocity graph. Let me show you what I mean. Okay. Let's see if this will work. So we're going to take a line directly from a change in our position graph. So right here, I'm going to draw a dotted line straight down, and it should be at 4. And I'm going to go all the way down on the graph to 4 on the other graph. And then the other break, the other change is at 6. And I carry that down all the way to 6. So go ahead and do that. Alrighty, now we're going to look at each section of our position graph. Okay, so the first section where the slope is 2. The slope is 2. That means what you're saying is the velocity is 2. So anywhere in that section, the velocity is 2. So I can go straight across like that. Take a second, make sure that sinks in a little bit. Notice something. In that first section where the slope equals 2, it's 2 everywhere in that section. Anywhere along there, the slope is the same. It's 2. So that's what I put in there. Now let's look at the next section. The slope is 0. So go down to here. You do it. Put the slope of 0 on there before you see what I do. Then pause me. All right, here's what I got for the slope. Right down at the bottom, the second section, it's 0. Go over to the third section. Let's do that, and then we'll connect them here in a second. The slope is 2/3. Okay? It's 2/3 the whole way along. 2/3 is about 0.6. So let's go a little up from 0.5 and draw our line straight over. Okay? That's a good enough graph. if you think you want to connect these, you can take a vertical line and go straight down and straight up to connect them, if that helps you a little bit. So let's look at this. Here's what this is saying. In this first section, right in here, okay, the velocity is 2 meters per second. Then, when we get to the end of this section, immediately, instantaneously, which isn't quite real, what happens? The velocity goes straight to 0, right there. And it sits there for how long? From 4 seconds to 6 seconds, so that's 2 seconds. Then immediately, it jumps back up, the velocity does, to 2/3, right in there. All right? Now you guys, this is weird. This is one of those that trips kids up a lot. Take a little time. Make sure you get this. You may want to listen again. Okay? But just take a second. Make sure you get it. All right. When you do, jump down, and here's your video lecture problem. Enjoy yourselves. Hope you're having a great day. Bye-bye.